Hi again, everyone. Professor Sebastian's back. We're on our Calculus 3 class notes in about the middle of page 68, and we're on our 14.7, section 14.7, where we're looking at extreme values. So the first theorem I want to talk about is the first derivative test for local extreme values. If a function f of xy has a local maximum or a minimum value at an interior point of its domain, so we're talking about an interior point of its domain, then the partial of f with respect to x at that point AB is equal to the partial of f with respect to y at that point AB, and they're both equal to 0. Or one or both don't exist. Okay, so for example, let's find the local extreme values of f of xy equals x squared plus y squared minus 4y plus 9. By the way, this is a paraboloid, so if I change it into kind of a standard form, that I'll jump down here first. We can see that f of xy, so I can complete the square with y squared minus 4y to get y minus 2 squared. So this 9 becomes a 5, right? I have to pull 4 of them in here. So this is a paraboloid, and you can see that it has a apex here, or vertex at this paraboloid of 0, 2, 5. Okay, so that's always going to be greater than or equal to 5, and that's why I didn't need any further information to know I had a local minimum. But so going back, the domain of f is the entire xy plane. We have no boundary points. There's no values of x and y that can't be plugged into here. If I look at the first partial of f with respect to x, then I get 2x, set that equals 0. That means x equals 0. Partial of f with respect to y is 2y minus 4, set that equals 0. I get y equals 2. So that tells us that we're going to have a local minimum or maximum, and it can only occur at 0, 2, or a local minimum or max can only occur at 0, 2, with a value of f of 0, 2, which is 5. So since I played around with the paraboloid equation and put it into sort of the standard form of a paraboloid, I can see that since x squared is always positive, y minus 2 squared is always positive, the function f of xy is always greater than or equal to 5. So that tells us there is a local minimum at this point 0, 2 with a value of f of 0, 2 equals 5.